Hi, we have AP Physics 1 past paper 2024. We are discussing the section free response questions. In this section, question number 3 carry the 12 points. The left end of the uniform beam of the mass M and the length L is attached to a wall by a hinge. As shown in a fig, this is the hinge and the uniform rod is showing is here. Now, one end of a string with the negligible mass is attached to the right end of the beam. This is a string is attached to the right end of the rod. Now, uh, attached to the above wall above the hinge at point 1. Like that, there is a point 1 which is from the right end of the beam is connected through the string. The beam contain remain horizontal. The hinge exert a force on a beam of magnitude Fh. Now the angle between the beam and the string is theta is equal to theta 1. That's the mentioning here, theta 1. Now the question is, the following rectangle represent the beam in a fig 1. On the rectangle, draw the label forces not component exerted on a beam. Draw each force as the distinct arrow starting on and pointing away from the point at which the point force is exerted. Okay. Now, first of all, there is a beam, so there is a gravitational force. We can say weight acting at always downward at the center of the beam. Why center? Because the beam is uniform. So if the beam is uniform, so force weight act at the center of the body. So center of the beam, the forces of weight act, but it is always directed downward. Now the tension, the act on the right end of the beam directed along the string toward the attachment of the point to the wall mean the string is pulling this beam in this direction. So that's the force I have directed through tension Ft. That's the tension force. Now the hinge force, hinge is on the left hand. The direction is not specified, but it must be balance the other forces to maintain the equilibrium because the beam remain in horizontal. So to remain the beam in horizontal, this force should balance the other forces. So I have drawn the hinge force in this direction. Okay. Now what's the question? The string is then lower to the wall to the point 2. First it was at the point 1, now it is at the point 2. The beam remain horizontal. Still the beam is horizontal. Angle between the beam and the string is theta is equal to theta 2. The dashed line represent the string as shown in a fig. The magnitude of the tension in a string is Ft1. Now magnitude of the tension new angle is Ft2. Now the indicate which of the following correct compare Ft2 with the Ft1 where Ft2 is greater than Ft1 less than or equal to. Briefly justify your answer using the qualitative reasoning before beyond referring the equation. Now, first of all, I have mentioned the answer. Ft2 is greater than Ft1 mean in fig 2 the tension is in new condition should be greater as compared to in previous case. Now, reason why keep the beaming to keep the beam from rotating, the counterclockwise pull from the string must cancel the clockwise pull by the weight. So that's the answer. There is a two forces balance must balance each other. Only vertical component tension Ft sine theta actually providing the torque about the hinge to balance the torque from the weight. Mean there is that tension in this string. The one of the component that is acting upward direction is balanced by the downward. That's the force producing torque in this direction. This force is producing in this direction. So they must be balance each other. When the string is moved from point 1 to point 2, angle theta gets smaller. Theta 2 is less than theta 1. From the beam remain horizontal, balancing torque must remain constant. So theta is smaller, sine theta is smaller, larger tension is needed to produce the same vertical component to balance the beam. As the sine theta is decreasing, Ft should be increasing in that case to remain the product same. So hence the total pull or tension of the string must be increased. So that's the answer. In new scenario, Ft2 is greater than Ft1. So that's the reason. Now Starting with the Newton's second law of rotation, derive the expression of the magnitude of tension in a string. Express your answer in terms of m, theta, and physical constant as appropriate. Bring your derivation, writing the fundamental principle or equation from the reference book. Now, Newton's second law of rotation in static equilibrium, we said net torque about any point is zero. Sum of torque acting on a body should be equal to zero. Let's choose the hinge as a pivot. Because hinge is the pivot, so the forces of hinge exert no torque. Because the moment arm becomes zero in this scenario, R is zero because force is passing through the pivot point, so torque should be zero from the hinge force. Only the torque comes from the weight and the tension. So there are the two forces and there is a two torque, one from the gravity, one from the tension. If we see, the gravity is clockwise direction and the tension is counterclockwise. So that's the reason there is a negative sign. Counterclockwise torque is considered negative. Now, and tau is basically R into F. So R is moment arm, F is a force. So in this case, the force is mg, moment arm is equal to L by 2 in case of gravity. Now, in case of the tension, Ft sine theta, as we seen the earlier, only the vertical component is capable to rotating the torque, and L is the moment arm. So mg and the negative sign, we move the whole factor to the other side. L is cancelled. From there, we Ft is equal to mg sine divided by 2 sine of theta. Now, is your drive equation in part C consistent with your justification in part B? Explain your reasoning. Now, the answer is yes, it is consistent. As we come to the equation, Ft is equal to mg divided by 2 sine theta. Ft is inversely proportional to the sine theta. When the string is lowered, theta is decreased, sine theta decreases. So Ft increases. As the sine theta is decreasing, Ft should be increasing. This matches our conclusion in a part B. Now the last part of the question is, the string is cut, beam begins to rotate about the hinge with negligible friction. On the following axis, sketch the angular speed of the beam as a function of time for the time interval while the beam falls before the beam becomes vertical. Okay, as the once the string is cut, only gravitational force act creating the torque. Now at time is equal to zero, just before cutting the string, the angular speed of the beam or rod is equal to zero. When it is cut, the time increases, gravity causes the beam to rotate, increases the angular speed. So that's the reason the speed is increasing at that moment. After that, going in, instead of straight, it turn downward. Why? Because the beam rotate downward, effective lever arm of the gravity decreases, mean moment arm is decreasing, so torque decreases. So angular acceleration decreases, but the angular speed still increase, but more slowly pace. So speed is increasing, but the pace of change of increasing changing speed is going to slow. So that's why it's move in this direction. So that's the reason. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share it with your friends. Okay, take care.